Our project focuses on the HeartBleed vulnerability in OpenSSL, a major flaw that exposed sensitive data from server memory due to poor input validation. This issue is important because it shows how a simple coding mistake can lead to large-scale security breaches, affecting millions of users worldwide. Our teaching aid is an interactive lab and presentation that explains how HeartBleed works, lets users identify the bug in the code, and demonstrates how a proper fix prevents data leaks. By exploring it, learners gain hands-on experience with secure coding, validation, and patch management, key skills for preventing future vulnerabilities. Hello, welcome to our walkthrough of the HeartBleed attack. We have two VMs, which are the attacker and the victim VM. While on the attacker VM, we want to make sure it's on the NAT network. And then we go to the victim VM and make sure that VM is also on the NAT network. We use the following command on both VMs to confirm their IP addresses. While on the attacker VM, we want to reconfigure the IP of the website we are attacking to the IP of the victim VM. Then, we confirm the change with the following command. Now that we are on the website set for attack, we need to log in as an admin. When we have logged in, we will then have to find some members to interact with on the website. We do this by adding some friends and then sending them a message. After we have sent the message, we will then go back to the attack VM and run an attack file on that website, which we hope to get the message we sent earlier somewhere in memory. A warning appears showing that the server is vulnerable, along with the login credentials used on the site. We let the script run for a period of time. During execution, it extracts text from memory. As you can see, several pieces of text are stored in the computer's memory. After running the script a few times, we eventually retrieve the message that was sent to Bobby. We now see our message that we sent to Bobby. We then go back to the website to confirm that the message we sent to Bobby is the same message that was leaked through the attack.py script. Now that we have seen our message leaked, we want to know the boundary value for the input length variable. The heartbeat query will receive a response packet without attaching any extra data, which means the request is benign. The boundary, the largest length that does not produce a leak, was 22 bytes. Next, we want to experiment with different lengths and see what the result will be. It is important to remember that smaller lengths leak less data. So if you want to retrieve more information, you will need to increase the length. Thanks for listening to our walkthrough of the HeartBleed attack. We hope you learned how to set up 2 virtual machines to simulate the attack and explored some examples of malicious payloads that can be sent to a vulnerable server. It's been a pleasure, and good luck on the quiz.